Hi, in this lesson we are going to see how to sketch the curve. There are 7 guidelines: domain, intercept, symmetry, asymptote, intervals. We are going to see intervals. Already in my previous 4 videos we have seen the first 4 points. Now intervals. Next we are going to see local maximum or minimum and concavity. Okay, now I am going to illustrate intervals of increase or decrease with the 10 examples. These examples are rational function, trigonometry, ln, exponential. So if you are able to solve all the different kind of sums, you have to find the intervals of increase and or decrease, you probably can solve any sums, because I have chosen very particularly different kinds. Now, question number 1, x cube plus x. This is okay. How to find intervals of increase? What is intervals of increase? This curve is like this. It is intervals of increase. When it will be increasing? When f dash x is greater than 0. This is called, from here to here it is increasing. Okay. Then from here to here it is decreasing. So this is called, when will it happen? When f dash x is less than 0. So for increasing, f dash x should be greater than 0. For decreasing, f dash x should be less than 0. Okay. Now my first example, x cube plus x. This is f of x. If you differentiate 3x squared plus 1, 3x squared is always positive. X squared is positive, 3 is positive, plus 1 is positive. So it is continuously increasing, minus infinity to infinity. There is no intervals of decrease. It is increasing minus infinity to plus infinity. Okay. Question number 2, x minus x squared over x squared minus 3x plus 2. You first factorize. If there is a rational function, you try to factorize first x over 1 minus x, x minus 2, x minus 1, denominator cancel, minus x over x minus 2, x over 2 minus x. Okay, x over 2 minus x is question number 2, simplified form. Now differentiate. 2 minus x times 1, that is quotient rule, v u dash minus u v dash. 2 minus x, if you differentiate, minus 1. Then v square, 2 minus x square. Okay, 2 minus x minus 1 plus x, 2 over 2 minus x whole square. Okay, now it is over. Then example number 3. Okay, when it is increasing, this is f dash x. When will it be positive? Any square number is always positive. So whatever x value, 2 minus x square is positive, 2 is positive. So it is increasing minus infinity to plus infinity. But there is one point, when x is not equal to 1 and 2, it is not, the function is not valid. So instead of minus infinity to 1, you put minus infinity to plus infinity, you put like this. Before giving the what is called intervals of increase, you should know what is the domain. That is the main criteria to tell the intercept, to tell the intervals. Third example, x over square root of x squared plus 1, square root of x squared plus 1, uv formula, u quotient rule, square root of x squared plus 1, x if you differentiate 1 minus x, square root of x squared plus 1 of x squared plus 1 power minus of, then x squared if you differentiate it is 2x, this 2 will cancel, by denominator v squared, square of x squared plus 1, square of square root x plus 1 is, it will be that, this 2 and this will be cancelled. Okay, now do it, square root of x squared plus 1 minus x over minus x squared over square root of x squared plus 1 divided by x squared plus 1. Zoom it. So x squared plus 1, I am making what is called LCM. I am multiplying it will be x square plus 1 will come, minus x squared over square root of x squared plus 1 will come, divided by x squared plus 1 will come. Okay, now I just write it here. This x squared plus 1 minus x squared, this x squared minus x squared will be cancelled. So 1 over square root of x squared plus 1, that if it is coming into the denominator, 1 over square root of x squared plus 1 over 3 by 2 will come. Here x squared is always positive, 1 is positive, so this one always, f dash x is always positive. So the intervals of increase is minus infinity to plus infinity. There is no intervals of decrease. Please note it down completely. Cut. Okay, now we are going to the fourth example, x times x minus 4 cube. This is f of x. To find the intervals of increase or decrease, you have to differentiate product rule. X 3 times x minus 4 square plus x minus 4 cube. X, if you differentiate 1, x minus 4 square multiply 3x plus x minus 4 plus 4x minus 4, x minus 4 square plus 4 times x minus 1, 4 times x minus 1. I just rearrange it, x minus 4 square. I repeat, it is a product rule. X minus 4 cube, I differentiate 3 times x minus 4 square plus x minus 4 cube. X, if you differentiate, it is 1. So now I take out x minus 4 square. Take out common, I am factorizing. 3x is there, plus here what will be there? If I take square, it is cube, 1x minus 4 is there. So x minus 4 squared, it is 3x plus x is 4x minus 4. So x minus 4 squared, 4 if I take out, x minus 1. So 4 x minus 1, x minus 4 squared. Okay. So this is f dash x. When it will increase, this is x minus 4 squared is always positive. So it is, there is no rule. 4 always positive. When x is greater than 1, it is increasing. When x is greater than 1, f dash x is greater than 0. That is increasing. When x is less than 1, f dash x is less than 0, decreasing. So 1 to infinity increasing, minus infinity to 1 decreasing. Next is, note it down, next is 2x squared over x squared minus 1. Okay, differentiate quotient rule. Next example, x squared minus 1, 2x squared, if you differentiate 4x minus 2x squared times 2x over 2x squared minus 1 squared, 4x cube minus 4x, 4x times x squared is 4x cube, 4x times minus 1 minus 4x. This is minus 4x plus 4x cube minus 4x will be cancelled, minus 4x over 2x squared minus 1 squared, minus 4x over 2x squared minus 1 squared is f dash x. This square is always positive. So here minus is there. So when x is less than 0, f dash x is greater than 0. And it is increasing. But so when x is less than 0, f dash x is greater than 0, increasing. When x is greater than 0, f dash x is will be less than 0, so it is decreasing. But the problem is it has the domain restriction. Always when you are doing intervals of increase or decrease, you check the domain. Domain is x is not equal to minus 1 or 1. Okay, so minus infinity to minus 1 it is increasing, then minus 1 to 0 increasing. Zero to 1 decreasing, 1 to infinity decreasing. Note it down. One to infinity decreasing. Note it down. Okay. Now question number 6. Square root of x squared over square root of x plus 1. X squared over square root of x plus 1. Quotient rule. Square root of x plus 1 is keep as it is. U dash is 2x minus u. V dash is of x plus 1 to the power of minus of. Sorry, it will be of, yes, minus of divided by x plus 1. Square of square root will be common. So 2x square root of x plus 1 minus x squared over 2 square root of x plus 1. Make it LCM. Make it LCM. Just multiply is 2x by times 2 is 4x. Square root of x plus 1 and square root of x plus 1 will become x plus 1 minus x squared over x plus 1. So 4x squared plus 4x minus x squared will be x plus 1. This, if it comes here, it will be x plus 1 power 3 by 2, because this we come out, denominator goes out. So 2 times x plus 1 power 3 by 2. So what will happen if we further simplify? It will be 3x squared plus 4x over 2x plus 1 power 3 by 2. Okay. If you take x out, 3x plus 4 over 2x plus 1 power 3 by 2. Okay. So what will happen when will it be negative? When x will be minus 4 over 3. X cannot be minus 4 over 3 because it has the domain restriction. X is greater than minus 1. So this ruled out. Focus here. When x is less than 0, f dash x is negative. So it is decreasing. But x is less than 0, there is also restriction. Minus 1 to 0, f dash x is negative. So decreasing. When x is greater than 0, f dash x is positive. So it is increasing. So the limit, the intervals is minus 1 to 0 decreasing, 0 to infinity increasing. Note it down. Question number 7, x ex. X ex you can easily differentiate x times ex u v dash plus v u dash. X differentiate, it is 1. Take e power x common, x plus 1. E power x is always positive, so x plus 1 will be greater than 0 when x plus 1 will be greater than 0 when f dash x will be greater than 0. So x plus 1 is greater than 0 means x is greater than minus 1. So when x is greater than minus 1, f dash x is increasing. So it is increasing. So minus 1 to infinity, it is increasing. Minus infinity to 1, decreasing. Note it down. Note it down. Next example. Now we are going to see with the example number 8, cos x over 2 plus sin x. This is f of x. Find the interval of cos x over 2 plus sin x. Find the intervals of increase or decrease. Okay, first it is a quotient rule, 2 plus sin x. Cos x, if you differentiate, minus sin x. Put the bracket, minus cos x. If you differentiate to 2 plus sin x, it will be cos x. So what will happen? Denominator is square, 2 plus sin x whole square. So minus 2 sin x minus sin squared x plus minus cos squared x divided by 2 plus sin x whole square minus 2 sin x. If I take minus out, it will be 2 sin x plus sin squared x plus cos squared x will be 1. Okay, so 2 plus sin x whole square. Okay, so when will it be positive? This one, when 2 sin x plus 1 is negative, when 2 sin x plus 1 is negative, f dash x will be positive. When will it be negative? 2 sin x is less than minus 1, sin x is less than minus 1, minus 1 by 2. Okay, when sin x is less than minus 1 by 2, f dash x is positive because of this is also negative sign. So this negative sign and this negative sign will be positive. So when sin x is less than minus 1 by 2, it is positive. So in that, when this sin x is off is equal to 30 degree, okay, plus off. So it is a third quadrant is, fourth quadrant is negative. Third quadrant is 180 plus theta. Fourth quadrant is 360 minus theta. So 210 comma 330 degree, it is increasing. So increasing 210 to 330 degree. Decreasing 0 to 210 and 330 to 360. Got it? Note it down. So I repeat, v u dash minus u v dash by v squared. I just rearrange it. I took minus out. Okay, 2 sin x, since it is negative, 2 sin x plus 1 should be negative. Then only f dash x will be positive. 2 sin x plus 1 is negative. So 2 sin x is minus 1, less than minus 1. Sin x is minus of So sin x when will be minus up at third quadrant and fourth quadrant, half is equal to 30 degree. So 210 to 330 degree, it is increasing. That time f dash x will be positive. Okay, so 0 to, then the reverse is 0 to 210, it is decreasing. 330 to 360, it is decreasing. Note it down. Okay, question number 9. Note it down. Question number 9. Ln 4 minus x square. Ln 4 minus x square, if you differentiate 1 over 4 minus x square, if you differentiate minus 2x over 4 minus x square. Okay, when will be 4 minus x square means it will be positive only when minus 2. This is the domain. Domain is minus 2 to x should be less than 2, at the same time greater than minus 2. So when will be minus 2x, when will it be f dash x positive? When x is negative. When x is negative, f dash x is positive. So x is less than 0, but our domain is greater, so x should be, in this case, f dash x is positive, it is increasing. 0 to 2, it is f dash x is negative, it is decreasing. Okay. Question number 10. X cube over x squared plus 1. If I just simplify, by the time you would have known it, we have done so many quotient rule. F dash x is equal to x squared over x squared plus 3, x squared plus 1 whole square. This is always positive, all are square. So minus infinity to plus infinity, it is increasing. Thank you for watching all my videos. See you then.